Hi, everyone. So similarly to what we did with the numbers back in section 0.1, let's do a Venn diagram for various types of expressions in X. So we've talked about polynomials, the simplest kind, and that included numbers, like real numbers, like 1, pi, negative pi, and so forth. Numbers, constants, count as polynomials. Also things like x to the 7th plus x, or that 4x cubed guy we saw earlier, all right? Those are polynomials. Now, all polynomials are also rational expressions because you can always put polynomials over 1 and get a rational expression. A rational expression can be expressed as a polynomial over a polynomial that's not the zero polynomial. The simplest rational expression that's not a polynomial is 1 over x. 1 over x is not a polynomial because even though 1 over x can be written as x to the negative 1, you're not allowed to have negative exponents on x for a polynomial, but you can have negative exponents on x, negative integers on x for a rational expression. Every rational expression is also an algebraic expression, but you also get guys like these, like the square root of x or the cube root of x. The square root of x can be written as x to the 1/2. This is not a polynomial because you need integer exponents in order to have a, in fact, non-negative integer exponents on x to have a polynomial. Again, 1/2 is not an integer, so it's not, so x to the 1/2 cannot be a rational expression because you're not allowed to have exponents like 1/2 or 1/3 on x for a rational expression. So the square root of x is in some ways the simplest algebraic expression in x that is not rational, or for that matter, a polynomial. Now, beyond the algebraic, now we're going to focus on algebraic expressions in chapters 0, 1, and 2. Then in chapter 3, we're going to start talking about exponential and logarithmic expressions, like 2 to the x, or ln of x. These are not algebraic. And in chapter 4, our old friends, sine of x, cosine of x, and so forth, even inverse sine of x. Those are not algebraic. We're going to see these in chapters 3, 4, and beyond. All right, so a quick recap. A rational expression in x can be written as a polynomial in x over a polynomial in x that's not 0. Bear in mind, you can have these expressions in y or z or whatever, but let's say x for now. Right. Here's some examples. 1 over x is the easiest. This is more complicated, but you still have a polynomial over a polynomial. This is a rational expression in x. And again, every polynomial is a rational every polynomial in x is a rational expression in x because you can just stick the guy over 1. An algebraic expression is allowed to have non-integer rational exponents like 1/2 or 1/3 or 5/7. The cube root ultimately becomes a 1/3 as an exponent, right? I call this expression algebraic. Some books object to the pi there, but I call this expression algebraic. It's kind of like a rational expression where you're allowing for exponents on x like 5/7 and 1/3. Bear in mind, you can always have weird things like 3 to the pi. If it's all constant, that's always fine. Well, although, again, some books quibble for algebraics, but I say that's fine even for an algebraic expression. All right, so a taxonomy, in a way, a hierarchy of expressions in x. Next up, how do you factor QDs, quadratic trinomials, and more?